All right, guys, we're going to be talking about the next the next non-renewable energy, which is nuclear. So I want you to know that I introduced to you all of fossil fuels, but we mainly talked about coal, right? Because coal is used for electricity production. So now we're going to learn about nuclear, which is not a fossil fuel, but it does have a lot of similarities to coal. So we're going to start with nuclear. So, like all fossil fuels, nuclear is a non-renewable resource. That means even though it's found in our Earth's crust and in most rocks, it will run out. Once you use it, it's gone. So it's one of the 4 non-renewable resources. Its main use is electricity production. And this is why we're learning about this one next before petroleum and natural gas. Another use for nuclear power is the industry. So like coal, its number 1 use is electricity. Its second use is in industry. There's a lot of things that are made from nuclear in the industry, like medicine and missiles. Obviously, it's not always a good thing. And when you think of nuclear, I'm sure somewhere in your mind you think it's not the best idea. So why would we have chosen nuclear over fossil fuels? Well, since fossil fuels have a time span and they will run out, we're thinking of other things that we can use in case they run out. Coal, although it's the most abundant fossil fuel and it's great for making electricity, it does have a lifespan. Like in 200 years, there's going to be no more coal. So they're thinking of ways to still produce electricity without coal. And the good thing is when you use nuclear power to produce electricity, it's going to have practically no emissions. I put limits emissions because we're definitely going to talk about things that happen during nuclear power production, but it doesn't produce carbon dioxide, nitrous oxide, sulfur oxides, which is high. The other reason why nuclear power is so great is when we put coal in the boiler to make heat, 1 ton of coal is equivalent to an entire, 1 little pellet of uranium is equivalent to a whole ton of coal. So 1 pellet of uranium will produce the same amount of heat as an entire ton of coal. So uranium pellets have a lot of power. All right, so how does nuclear power produce heat? This is called fission, and this is what I'm going to describe now. This should be a GIF, but for some reason it's not working. Let me see if there. So you have a neutron, and this neutron is actually going to hit this, which is my nuclear power, which is uranium-235. Unfortunately, the GIF is not working. There it goes. So scientists figured out that if you get a neutron and you hit uranium-235, it's going to start a reaction. Once the neutron hits the U-235, which this is nuclear power, this happens. And again, the GIF is super slow. The U-235 is going to split into 2 daughters, we're going to call them. So it's going to split this, but it's going to make more U-235. More neutrons are going to be made, and then there's going to be massive amounts of heat energy released. I'll stop the video and show you a image. All right, I went and got another GIF from the internet. So here's my neutron. It's going to hit the U-235. It's going to split into daughters. Those 3 little dots are more neutrons. And then you saw the massive amount of heat energy. I'm going to show it one more time. Neutron hits, splits, and in between here is massive amounts of heat. It actually didn't show it here, but that's the goal, is how to make heat, because that heat needs to go into the reactor, which is going to be shown to you now. Now, the scary part is that those neutrons are going to go and hit the daughters, like you're seeing here. This GIF is actually working. All that's heat, and then more heat energy, and this is just going to go on and on and on, and it's like an uncontrollable chain reaction, which means This technology has to be made in a way to prevent that reactor from exploding, because heat and heat and heat, it will not stop. So we have to stop this reaction. So this is how it works inside. So this reaction is so dangerous because there's obviously radiation, that unlike a coal-powered plant, they build this reactor with a structure that's called a containment structure. That structure is made up of steel and concrete, and it's the size of, let's say, our classroom. That's how thick those walls are. This is to maintain radiation, and everything happening inside here is protected from never coming outside. Now here is a reactor vessel. In there is where the fuel rods are, where fission happens. So these little sticks here are fuel rods, and this is a picture of an actual nuclear power plant, and those are the fuel rods. Inside the fuel rods, this is going on right here, what I was showing you before. So this and this is inside the fuel rod, and it's doing fission, okay? So because it's an uncontrollable chain reaction, so you know, there's this thing called control rods, and they're gonna absorb all the neutrons. Because if we collect the neutrons, then we're gonna stop fission from happening. So that's the way they control this reaction. And then because there's so much heat, we're also gonna add a coolant to keep the heat low, okay? So all of that is happening right here. Now here's a bigger visual for you. So uranium, I'm going over it again. Uranium is placed in these fuel rods, and that's called nuclear energy, right here, inside the reactor core. Fission occurs, and that's gonna make heat energy inside the reactor vessel. Water is added, so the water comes from here, from the condenser, but water is added to make steam, which is gonna spin the turbine. So steam, spin the turbine. That turbine is attached to a generator, and the generator sends the electric current, which makes electricity to your home, okay? And then you've got these cooling towers, which are not, I didn't show you right here, but they actually capture the heat. But you know what? We're gonna go like this, and you don't have to worry about that, okay? So you could scratch that out of your notes, because the cooling tower is not even in the picture. All right. This is what a fuel rod looks like. All these uranium pellets go inside this thing, and this is what the nuclear power plant looks like, the steel structure. These are what uranium pellets look like. So these are actually just visuals of what it actually looks like. Biggest issue, obviously, we know that one uranium pellet produces a lot of heat, but the biggest issue is that if we have any accidents, then we're in trouble. But we're gonna consider it a great thing if there were no accidents, because there's a lot of it. It's gonna make a lot of heat, okay? The biggest issue is waste. There's a lot of radiation when you undergo fission. Because of the waste, because we have to throw away and discard all this waste, the energy drops in terms of being so good for producing electricity. And obviously we have to fear of any accidents or war from having your hands on this valuable resource. A scary valuable resource, I should say. Another disadvantage is that the power plant lifespan is not long. There's so much radiation in the power plant that they literally have to tear it down after about 70 years. So when you build a nuclear power plant, you have to keep in mind that you will be closing after 70 years or having to rebuild the whole plant. So we talked about waste. I'm going to narrow this down a little bit. Waste is produced during mining, during producing the actual uranium, and during fission, okay? This would be the fission. This are mining. I'm not going to cover any of this stuff, but we produce waste during all that. And you don't have to know the difference between low level, intermediate level, and high level, okay? But we do have all these different levels of waste. What I want you to know is how we throw it away. So if it's low level, okay, waste, which is produced during mining, we're just going to put it in these barrels and we're going to bury it. Okay. If it's high level, which is only from the fuel, they have to put those little pellets. So I'm going to go back here. These pellets of uranium, I'm going to show you the picture again. These little teeny weeny pellets, after they can't make any more heat, they have to be dumped in this pool, sometimes for 10 years, sometimes for 20 years, so that the radiation can go away. Then they're going to take all those pellets and they're going to put them in these drums, which look like this, and then we're going to bury them. So it's a lot more issues. Biggest problems with nuclear disasters are accidents. The worst environmental disaster of a nuclear power plant happened in Chernobyl. In 1986, this reactor actually exploded. And I have videos. When we're back together, I'm going to show you these videos of how this happened. But today, this is a brand new dome. There's still so much radiation in Chernobyl that they had to build this dome to contain the radiation. This is the second dome they built since 1986. Another disaster happened in the United States of America in 1979, and this happened in Pennsylvania. It's called 3 Mile Island. And then recently in 2011, because of an earthquake, one of the nuclear reactors in Fukushima, a power plant in stopped working because they lost power, and then radiation was emitted throughout most of the area.